Hello students, I'm Smriti coming to you with the second part of wave optics. Here we will prove laws of reflection and refraction on the basis of wave theory. In previous video we discussed about Huygens principle. Here we discuss about three major points. One is each point on the primary wavefront is a fresh source of new disturbance called as secondary wave or wavelet. That wavelets are spread in all direction with the speed of light in this medium. This one is the second point. And the third point, if we draw tangent on the secondary wavelet, we got secondary wavefront. The tangential surface is the secondary wavefront in forward direction of wave. Okay student, you remember these three major points. On the basis of this Huygens principle, we prove that laws of reflection and refraction. Okay, so let's start the topic, laws of reflection. So here we consider a reflecting surface xy and a plane wavefront AB. This one is the plane wavefront. This reflecting surface is perpendicular to the plane of board. If we take this one is the reflecting surface, this reflecting surface not lie on the board. This is perpendicular to the plane of the board. And you written in your exam that the reflecting surface is perpendicular to the plane of paper. Okay? Because here in your exam this one is the paper. You draw the diagram on paper. Now this one is the plane wavefront, which is also perpendicular to the plane of board. And these are two incident ray. This two incident ray is always perpendicular to the plane wavefront. We know that student? In our previous video also we discussed about it. In case of plane wavefront, we always got parallel rays. And these parallel rays are perpendicular to the wavefront. Next, here according to Huygens theory, what happened? Every point on the primary wavefront, this AB is the primary wavefront, you written that AB, this one is the primary wavefront. So every point in this primary wavefront is act like a source of new disturbance. So within t second, what is the distance covered by this wave? Okay. So here this point is a source of new disturbance and we got secondary wave. So within this t second, what is the distance traveled by this wave? Take as this one is the distance traveled by this wave. In t second it reach at point C. That means what is the distance it covered? We know the student, the distance equals to speed into time. So what is the speed of this wave in this medium? Take that speed of wave in this medium, that is v. So what is the distance it covered? The distance equals to speed into time. What is the speed? That v is the speed. In which time we take the distance? That is the time t. So the distance is vt. That means from A to C, this distance is vt. Okay. In t second, it covered the distance vt. At the same time, d also behave as a fresh source of new disturbance and this wave is propagated to the same medium. The secondary wave is also propagated to the same medium. Take as this one is the distance covered by the wave. Now, at same t second, here we behave like the source of new disturbance, and at same t second, it also travel the path bt, and this one is the new position. Take as this new position D. Okay, that means A to C जितना path cover किया है wave, B to D same distance, ये wave same distance cover करेगा. Okay, now the secondary wavelet. Now we draw the tangent over the secondary wavelet in forward direction. We draw the tangent over the secondary wavelet. That means we draw the tangent on point C over the point D. This gives us the secondary wavefront called as reflected wavefront. And this one is the incident wavefront. Now, this reflected ray are propagated along the direction of reflected wavefront. So, we got these two reflected ray. These two are the reflected ray, and these two are the incident ray. At point B and at point C, we draw normal. Okay. Now, student, we already know that the angle between incident ray and normal, this angle is called as angle of incidence. And here, the angle between reflected ray and normal is called as angle of reflection. बट यहाँ पे कुछ बात अलग है, ये समझ लो बेटा. क्लियर हो जाएगा ये टॉपिक और हम प्रूव करने के लिए हमें इजी हो जाएगा. सो क्या होता है, दिस वन इज द इंसिडेंट रे एंड दिस वन इज द इंसिडेंट wavefront. This one is the incident ray. Yes. So this incident ray and wavefront is perpendicular to each other. This one perpendicular to each other. Yes. So if this is the angle I, this is the angle of incident, then what is the angle? Here, what is the angle? This angle is 90 minus I. Obviously. समझ आ रहा है? नेक्स्ट, यहाँ पे जो हम नॉर्मल ड्रॉ कर रहे हैं, ये नॉर्मल टू रिफ्लेक्टिंग सरफेस, देख लो डायग्राम में, देख लो नॉर्मल टू रिफ्लेक्टिंग सरफेस, ये क्या है? परपेंडिकुलर है. नॉर्मल टू रिफ्लेक्टिंग सरफेस परपेंडिकुलर है. अगर ये एंगल 90 माइनस आई हो गया, तो ये जो टोटल एंगल है यहां से यहां तक, ओके, ये कितना होगा? सेम आई. यहां से यहां तक इतना सारा 90 डिग्री है. ये अगर 90 माइनस आई हो गया, तो यहां से यहां तक कितना होगा? आई होगा. ये सेम प्रोसीजर मैं उस तरफ भी कर रही हूं, तुम लोग चेक कर लो, समझ लो एक बार. ओके, दिस इज एंगल ऑफ रिफ्लेक्शन. हियर दिस वन इज द रिफ्लेक्टेड रे. This reflected ray perpendicular to the reflected wavefront. So this one is the 90 degree. If this angle is R, then what is this angle? This angle is 90 minus R. Yes. Also here, what happened? The angle from normal to reflecting surface, this is perpendicular. अगर यहाँ 90 minus R हो गया, तो ये जो रिमेनिंग पार्ट बचा यहाँ पे, ये कितना होगा? ये कितना होगा? समझ आ रहा है? सो हम यहाँ पे क्या पा रहे हैं? दैट एंगल ए BC is equals to angle of incidence and angle DCB is equals to angle of reflection. So student, in our ray optics, we know that the angle between incident ray to normal, this is angle of incidence. The angle between reflected ray to normal, this is angle of reflection. But यहाँ पर the angle between incident wavefront to reflecting surface, this angle is called as angle of incidence. And the angle between reflected wavefront to the reflecting surface, this angle is called as angle of reflection. Clear? Now हम यहाँ पे two triangle ले रहे हैं. Triangle 1, this one is ABC and another triangle BDC. ABC, BDC. So इन दोनों ट्रायंगल में हम क्या सिमिलरिटीज देख रहे हैं? एक हो गया ये BC कॉमन, BC कॉमन. नेक्स्ट AC, this is equals to VT. Also BD, this was equals to VT. That means AC equals to BD equals to VT. Also, this one is the incident ray. This one is the incident wavefront. This incident ray and incident wavefront perpendicular to each other. Also, reflected ray and reflected wavefront also perpendicular to each other. That means this angle 2 are perpendicular angle 90 degree. That means the third one is angle BAC equals to angle BDC equals to 90 degree. BAC, BDC, these two angles are 90 degree. Depending upon these three concepts, these two triangle, that is BAC and BDC, these two triangle are similar to each other. So, angle BAC and angle BDC similar to each other. That means the angle ABC equals to DCB. That means here ABC, this is angle of incident. DCB, this is angle of reflection. That means angle I is equals to angle R. यही तो है laws of reflection, that angle of incident is equals to angle of reflection. On the basis of wave theory, also we proved that angle of incident is equals to angle of reflection. Clear? You clear, students? Next we go to that second one, net. Here what happened? एक बात याद रख लो और समझ लो, याद हो जाएगा. This one is the reflecting surface, this one is the incident wavefront, this one is the reflected wavefront. This incident wavefront, reflecting surface and this reflected wavefront perpendicular to the plane of both. Yes, that means what happened? This incident ray, this one is the incident wavefront, this one is the incident ray. Yes, this one is the incident ray. This one is the incident wavefront. That means this incident ray and this reflected ray, this one is the reflected ray and this one is the reflected wavefront. Yes, this incident ray, reflected ray and here the normal all lie in same plane. Yes, this incident ray, reflected ray and the normal all lie in same plane. So what happened here? This incident wavefront and this reflected wavefront and the reflecting surface is perpendicular to the plane of both. Okay student, यहाँ पे ये clear हो गया? ये हो गया laws of reflection. Next we go to that laws of refraction. Here we discuss about laws of refraction on the basis of wave theory. So student, here we consider a plane refracting surface xy. xy is a plane refracting surface which separate two medium. Take as this one is the rarer medium having refractive index mu1 and this one is the denser medium having refractive index mu2. Also take that the speed of light in rarer medium, that is v1. Next take that speed of light in denser medium, that is v2. Here I consider a wavefront, a plane wavefront AB. A plane wavefront AB. This one is a plane wavefront which is perpendicular to the plane of both, and this refracting surface is also perpendicular to the plane of both. Clear student? Now we consider these two are the incident ray. This one is the incident ray. We know that student, that incident ray are perpendicular to the incident wavefront. This one is the incident wavefront, and incident ray is always perpendicular to the wavefront. Here this incident ray perpendicular to the incident wavefront. And also student, in our previous class we discussed that in case of plane wavefront we always got parallel rays. Here we consider two parallel incident ray which is perpendicular to the incident wavefront. According to Huygens principle, that first point suggests that every point in a primary wavefront, is act like fresh source of disturbance, new fresh source of disturbance. That means here this point A behave like a new source of disturbance. Every point behave like a new source of disturbance. Here also B behave like new source of disturbance. Here the point A produce secondary wavelet. Here B also produce secondary wavelet. Okay. Now this secondary wavelet start from A and strike the refracting surface at point C. Draw the diagram first. This one is the secondary wave. Strike the refracting surface at point C. Okay. So in t second, what is the path covered by the secondary wavelet? In t second, what is the distance traveled by the secondary wavelet? We know that student, that distance equals to speed into time. So here in this rarer medium, what is the speed of this wavelet? The speed of this wave, that is v1. In which time it covered? The distance. In t time it covered this distance. So what is this distance? This distance equals to v1t. This distance is v1t. A to C, that is v1t. At same t second, here t second we determine the distance from A to C. At same t second, the wavelet produced at point B and propagated in denser medium. At same t second, wavelet produced at point B also, but it propagate in denser medium. Then what is the path covered by this wavelet in denser medium? Also in t second, we know that student, in denser medium the velocity of this wave, that is v2. In Okay, in denser medium velocity of wave, that is v2. So in t second, the path covered by b, that is v to t, okay. Then we draw the diagram. Student, here what happened? This one is the actual path of the incident ray. Okay, this one is the actual path of the incident ray. But we know that when they passes from redder medium to denser medium, it deviates its path. So it bent towards the normal. So here we draw the diagram like this. Okay, this one is the propagated wavelet. Okay, and this is the distance traveled by the wavelet, that is v to t. So student, here what happened? B is a point which acts like fresh source of disturbance, and here wavelet is produced, and that wavelet is produced and propagated in this type. कुछ इस तरह ये प्रोपागेट होता है, समझ आ रहा है? So यहाँ पे कितना वक्त में यहाँ पे पहुंचा ना, t सेकेंड में कितना डिस्टेंस कवर किया, v to t. ये पॉइंट को मान लो ये पॉइंट d. Okay, here also same happened. This one is the source of disturbance and that wavelet is produced. That wavelet is produced like this. Okay, कुछ इस तरह propagate होता है. Now we know that student, if we draw tangent over the secondary wavelet, this one is the secondary wavelet, this one is the secondary wavelet. If we draw tangent over the secondary wavelet, it gives us secondary wavefront. So we draw the tangent. This tangent gives us the secondary wavefront, or we call as refracted wavefront. We call as refracted wavefront. And here what happens, student? That refracted ray is perpendicular to this refracted wavefront. How is the refracted ray? Which is perpendicular to the refracted wavefront, and this one is the refracted ray. These are the two refracted ray which is parallel to each other. That means this refracted wavefront is also a plane wavefront. Okay, this refracted wavefront is also a plane wavefront. Clear, student? इतना क्लियर हो गया? अब हम डिस्कशन करेंगे that how it obey laws of refraction. Okay, यहाँ से हम स्नेल्स लॉ को डिराइव करेंगे. स्नेल्स लॉ क्या था? sin i by sin r equals to mu2 by mu1. यहाँ से हम वो लॉ को डिराइव करेंगे. समझ आ रहा है? ओके, देखो कैसे डिराइव करेंगे. Here we first draw the normal. At point B and at point C, we draw normal. At point B and at point C, we draw normal. Then what happened? We know that, student, the angle between incident ray and normal, this is angle of incidence. Yes. And here what happened? The angle between incident ray and incident wavefront, this is 90 degree. If this angle is I, then what is this angle? This angle is 90 minus I. Yes. यहाँ पे देख लो. Two refracting surface, ये भी perpendicular to each other. ये एंगल कितना हो गया? 90 डिग्री. ये एंगल 90 डिग्री है. ये एंगल 90 minus I है. तो ये एंगल कितना होगा? Obviously I होगा. देख लो. ये I होगा, ये I, ये 90 माइनस I, टोटल मिल गया तो 90 हो जाएगा, तो ये एंगल हो गया I। समझ आया? ये समझ में आया? यहाँ पे क्या करना है बच्चों, हमें यहाँ से स्नेल्स लॉ को डिराइव करना है। So, how we derive Snell's law from this concept? So, first one we take the triangle ABC. So, we written that in triangle ABC, ABC. This is the angle I. Here we take about sine I. If this is angle theta, then this one is B, this one is P, and this one is H. Yes, we know that students sin theta equals to P by H. So sin I equals to P by H. What is P? This AC is P. And what is H? H equals to BC. Next, students, what do you mean by AC? The distance traveled by the secondary wavelet. The distance traveled by the secondary wavelet in rarer medium. So instead of AC, we put that value V1T by BC. Clear? Now go to another triangle, that is triangle BDC. देख लो triangle, देख लो BDC. In triangle BDC, here we consider about sine R. Achha student, this angle is R. So this one is B, this one is P, and this one is H. Yes. So same sin theta equals to P by H. In value of P, you put that BD by H, that is BC. Then what is BD? BD, the distance traveled by the wavelet in denser medium. What is this distance? That is V2T. So instead of BD, we put the value V2T by BC. When we take ratio between sin I and sin R, that is sin I divided by sin R is equals to, put the value, that is V12 by BC divided by V2T by BC. BC cancel. Then what we got? That is V1T by V2T. Here T also cancel. Next, what we got? That is sin I by sin R equals to V1 by V2. Yes, student? Refractive index, we know that V1 by V2 equals to mu2 by mu1, that is equals to mu21. Yes, that refractive index of second medium with respect to first medium. That means instead of V1 by V2, we can put that value of mu2 by mu1, that is equals to mu21. So that is sin I by sin R equals to mu2 by mu1, that is equals to mu21. This is Snell's law. Yes, sin I by sin R equals to mu2 by mu1. This is Snell's law. Yes, so here we proved Snell's law or derived Snell's law from Huygens wave theory. Also we derive another law, that incident ray, refracted ray and normal all lie in same plane. This is another law, we discuss on it. देखो बच्चों, क्या होता है, ये हो गया हमारा रिफ्रैक्टिंग सरफेस. यस, ये हो गया हमारा इंसिडेंट वेव फ्रंट, ये हो गया हमारा रिफ्रैक्टेड वेव फ्रंट. ये तीनों कैसे हैं? परपेंडिकुलर टू बोर्ड है. देख रहे हो, ये हो गया रिफ्रैक्टिंग सरफेस, रिफ्रैक्टेड वेव फ्रंट, इंसिडेंट वेव फ्रंट. ऑल आर परपेंडिकुलर टू द बोर्ड. यस, देखो और एक बात, ये हो गया हमारा इंसिडेंट वेव फ्रंट। यस, ये हो गया हमारा इंसिडेंट रे, जो कि इंसिडेंट रे इंसिडेंट वेव फ्रंट के ऊपर कैसा है, परपेंडिकुलर है। दैट मींस ये देखो, ये हमारा इंसिडेंट वेव फ्रंट परपेंडिकुलर टू द बोर्ड, ये हो गया हमारा इंसिडेंट रे दैट इज परपेंडिकुलर टू द इंसिडेंट वेव फ्रंट। यस, दैट मींस दिस इंसिडेंट रे lie on this board, lie on this board, कुछ इस तरह रहेगा। Likewise, this incident ray, this refracted ray, and this normal, okay, all lie in this plane of the board. That means incident ray, this refracted ray, normal, all lie in same plane. Okay, students, here we conclude laws of reflection and refraction on the basis of wave theory. In our next video, we discuss about interference.